Hello and welcome to the Math IPREP Part 1 practice problem video. So in this video, we're going to go over a worksheet with all kinds of problems and go over the same material we just learned in the Part 1 lecture video. So I'm going to go a little bit quickly through some of the material, and that's just because we did cover basically all of this already in that first video. So I'll give you a brief refresher and then we'll jump into the practice problems. Section 1, fractions. So fractions represent a portion of a full number. The top number of a fraction is called the numerator and the bottom is called the denominator. So the numerator is going to be the part and the bottom is whole. So how much of the whole do you have? So 1/2, you would have one part out of two parts, or half. So a little tip for remembering numerator from denominator is that the denominator is down. So let's go ahead and try some problems real quick. So we have converting from fractions to decimals. So we have some problems here. We have 6/138 equals 6 divided by 138, and that's equal to 0.0435. So as you can see, all you have to do to convert from a fraction to a decimal is divide. So let's go ahead and try a bunch of practice problems really quick. So first we have 1/2. So you're going to take 1 divided by 2. That's going to equal 0.5. Next we have 1/6. And this one is going to be 0.167. Next, we have 3 divided by 4. That's going to be 0.75. Now we have 2 divided by 9. I'll go ahead and write this one out again, just because it's nice to see it sometimes, just to remember what we're doing. So 2 divided by 9, that is equal to 0.22. And that bar right there that we see, which I should have put up here as well. So let me fix that really quick. It's going to be a repeating number. So that means that number goes on infinitely. So 0.22222 forever. And in problem B, it was 0.1666666 forever. Now, let's keep going. So E, we have 5 divided by 3. It's going to equal 1.66 repeating. On F, we have 45 divided by 74. Here we get 0.608. Next one, we can see it's 83 divided by 1054. And again, all you have to do here is just plug these into your calculator, and you'll get these answers. So 0.0787. And finally, we have 8/2, which is just equal to 4. So though that is part 1. So let's keep going. So now we have reducing fractions. So if both the numerator and the denominator of a fraction are divisible by the same number, then the fraction is reducible. The smallest number by which both the numerator and denominator is visible is called the least common factor. To reduce fractions, the least common factor of the numerator and denominator must be determined. And the numerator may then be written out as multiples of their factors. Any factor in both the numerator and denominator can then be canceled out. So let's go ahead and try some examples here. So as you see this example right here, you factor it out. So you have 144, which equals 3 times 2 times 3 times 2 times 2 times 2. We kind of just keep going like that. So here we have 6/8. So this equals 3 times 2. 8 can be reduced to 4 times 2. Cancel out those 2's. Equals 3/4. There we go. Next, we have 12/24. So this is going to be what? 2 times 6. You know, 6 is going to be 3 times 2. On the bottom, 24, so we have 2 times 12. We know 12 is going to be 2 times 6, and 6 is going to be 3 times 2. So then we cancel out. So we have 2's here, 2 here, 3 here, 3 here, 2 here, 2 here. So we're left with 1 over 2. So if there's nothing left on top, it's just going to be a 1. So 1/2. Cool. So next we have 4 over 8. So again, we're going to have 2 times 2 over 2 times 2 times 2. Once again, we see these canceled out, and we get 1/2. Let's go ahead and erase some of this to give us some more room. So we have 6 over 10. So when we multiply that out, we get 3 times 2 over 5 times 2. Cancel those out. You get 3 over 5. So 300 divided by 10. 30 times 10 is 300 over 10. Cancel that out to 30. Also, that you could definitely keep going there. So 30 times 10, right? Not necessarily the best way. It is the quickest, but it's not necessarily going to make sure you can check your answer, right? So the nice part of all this up here is you can check your answer as you go. You can see all your numbers. So let's try that real quick. So 3 times 10, so we have 2 times 150. 150 divided by 2 is 75. So 2 times 75, which is 3 times 25, which is 5 times 5. So down here we have 5 times 2. Cancel out the 5 and the 2, cancel out the 5 and the 2. And you get 2 times 3 is 6, 6 times 5 is 30, equals 30 over 1, which is equal to 30. Next we have 8 over 2, which I'll go this way for. So 8 is going to be 2 times 4. And we know 4 is 2 times 2. So 2 times 2 times 2 over 2. Cancel these out. 2 times 2 is 4, equals 4. All right, so then we can go down to 84 over 2. So 84 divided by 2 is 42. So you have 42 times 2 over 2. Cancel out the 2, equals 42. Let's keep going. So up here we have 7 over 21. So 7 is a prime number, so we leave that how it is. 21 is 7 times 3. We cancel out the 7s, equals 1 over 3. Down here we have 6 over 18, so we have 3 times 2 over 2 times 9. We know that's 2 times 3 times 3. Okay, we can cancel out the 2, the 3, the 2, the 3, equals 1/3 yet again. And then we can just keep going. So we got 92 over 120. So let's erase some stuff because this might take a little bit more space. So 92 over 120. So you have 92, which is 2 times 46. 46 divided by 2 is 23, which is a prime number. So 2 times 2 times 2 times 23, that's all that goes to. So you have 120, which divided by 2 is 60. So 2 times 60 divided by 2 or yeah, it's going to be 30, but we know it's not going to cancel out anymore, so we can just leave that at 30. So 30 times 2 is 60, 60 times 2 is 120. So we have 92 over 120. We can cancel out these 2's. And we're left with 23 over 30. So you have this one, and put that right here. So you have 33, which is going to be 3 times 11. All right, 396. We can go ahead and divide by 3 just to see if it works, and it does. So it's going to be 3 times 132. 132 divided by 11 is 12, which, as we know, 12 is 2 times 6, which is 2 times 3 times 2. And so as you can see, when you're factoring, you can kind of tailor it to your problem. So we know the above, the numerator, the 33, only has 2 factors, 3 and 11. So then we can kind of see if our denominator, 396, is divisible by those same numbers. So right away, I hit 396 on my calculator, divided by 3. That worked, which is why we got a 3. Then I tried divided by 11, and that also gave us a whole number. So I got to put the 11. And then I just finished with my factoring. And then we can cancel out like we've been doing. So 3's, the 11's, and what we end up getting is 1 over 12. So one more, and then we'll move on to another topic. So we have 60 over 96. So 60, you have 2 times 30, which is 2 times 15, which is 5 times 3. So 2 times 2 is 4, 5 is 20, times 3 is 60, perfect. Well, at the bottom, we have 96, which is 2 times 48, which is 2 times 24, which is 2. Oh, so here's that chance. Wow, the thing I was talking about in the last problem, right? We can tailor a problem. So now we're at 24, right? So 24 times 2 times 2. This is where we're at right now. So we can either divide this by 2 and go to 12. Actually, no, we'll just do that. So we have 24, so now we have 2 times 12, which is, and 12 is 2 times 6, times 3 times 2. All right, so then you see we have a 3 to cancel out. We have 2 2's to cancel out. So on top, we're left with 5. And on bottom, we have 2 times 2. So we're left with 5 over, 2 times 2 times 2. Oh, wait, hold up. I might have missed a couple. I think I missed 1, 2. Let's see, 2 times 2 is 4, times 2 is 8, times 3 is 24, times 2 times 2, yeah, 96. So I missed a 2. So there's 3 2's on bottom. So it's 2 times 2 times 2. So it's 5 8's. So that is that section of reducing fractions. Now move on to converting from improper fractions to mixed numbers. So improper fractions are fractions in which the numerator is larger than the denominator. So that number on top is larger than the number on the bottom. So some improper fractions may be reduced to whole numbers, like 8 over 4, for example. 8 over 4 is equal to 2. But in many cases, this is not how it works. So our mixed numbers are going to give us whole numbers and fractions. So we can see an example here, right? And we have our kind of step-by-step process how to do it. So to convert an improper fraction to a mixed number, the numerator must first be divided by the denominator. The remainder is left in the numerator over the original denominator. So what that looks like is we have 27 divided by 5, right? So we get is 5 remainder 2, because 5 times 5 is 25, but 5 times 6 is 30. And so there's not 30 because 30 is too large. It's over 27. So we have to leave it at 5. But we have 2 left, right? So 5 times 5 is 25, plus 2 is 27. So we have 5 remainder 2, or 5 2/5. So let's go ahead and try some problems together. So first we have 8 over 6. So how many times does 6 go into 8? Once. So what we get is 1 remainder 2. And I'm just going to put an R for remainder to kind of keep it simple and less cluttered. So we have 1 R2, or again, we take that remainder and we put it over our original number here. So or 1 and 2/6, which we know can be reduced in our last one to 1 and 1/3. All right, our next one, we have 7/6. So again, how many times does 6 go into 7? Just the one time. So we have 1. This time we have remainder 1. So we go to 1 and 1/6. All right, next we have 5/2. So how many times does 2 go into 5? 2 times, right? So 2 times 2 is 4. It's going to be, again, R1. So we take that 1, put it on top of our denominator. That gives us 2 and 1/2. All right, next up, we have 47 divided by 5, or 47/5. So how many times does 5 go into 47? We have 9, because 9 times 5 is 45. So you have 9, and how many left over? 2, so 9R2, 2 9 and 2/5. All right, we'll go to the next one. 22/3. How many times does 3 go into 22? If you put in your calculator, you'll see it's 7 point something. So you know right away it's 7 remainder. And how many are left over? What's 3 times 7 is 21. So just one more equals 7 and 1/3. All right, next up we have 17/4. So how many times does 4 go into 17? 4 remainder 1 equals 4 and 1/4. Awesome. Next we have 45 divided by 7. So many times does 7 go into 45? 6, because 6 times 7 is 42. Remainder 3. And that's going to equal 6 and 3/7. So 6 and 3/7. All right, next up we have 88 divided by 6. So how many times does 6 go into 88? It's going to be 14. So 6 times 14 is 84. So our answer is going to be 14. Remainder 4, which is equal to 14 and 4/6. Or if we reduce it, 14 and 2/3. Next we have 34/3. 3 goes into 34 11 times, with a remainder of 1 equals 11 and 1/3. All right, next we have 100/90. So how many times does 90 go into 100? Just the one time. So 1 remainder 10 is going to equal 1 and 10/90. Again, we can reduce to 1 and 1/9. So that is that. Let's move on to the next section. Arithmetic with fractions. So to multiply fractions, first multiply the numerators and then multiply the denominators. Remember to reduce the product whenever possible. So tip, reducing the fraction before multiplying can save a lot of time. So example, 9/10 times 1/5. We multiply the numerator, 9 times 1 equals 9, and the denominator is 10 times 5 equals 50. And that is our answer. So to add fractions, the fractions must have the same denominator. If the denominators are not the same, find the least common multiple. So we have 9, 10 plus 1, 5. The least common multiple is 10. So what we do is times both of these by 2. So it becomes 2/10, and then we can add them. And we see that down here, right? So if you need some refresher, we covered a lot of this in the first video, but go ahead and look at the screen, pause the video, and review really quickly. All right. So here is the summary of how we multiply, divide, add, and subtract fractions and decimals. So right now we're only working with fractions, but we will work with decimals in a little bit. So again, if you don't have this in your notes somewhere, I would recommend writing it down because this is some really nice information that will be very useful for you. All right, so let's go ahead and do some practice. So first thing we see, we have 3/4 times 9/10. So we can, of course, multiply those by each other. So 3 times 9 is equal to 27. 4/10 is equal to 40. And that is our answer. Also, then we have 1/2 times 1/2. It's the same thing. We multiply our numerator and our denominator. So we have 1 times 1 equals 1. 2 times 2 equals 4. Our answer is 1/4. Next, we have 5/2 times 3/4. Once again, it's the same process. 5 times 3 is 15. 2 times 4 is 8. So 15/8. In this one, we can turn into a mixed number, correct? So 8 goes into 15 once, remainder 7. So if you want me to put it as 1 and 7/8. All right, next we have 1/2 times 2/3. So multiply the 1, multiply those. So we have 1 times 2 equals 2. 2 times 3 is equal to 6. And this can be simplified to 1/3. All right, over here we have some addition. So we have 1/2 plus 1/2. So do they have a common denominator? Yes, they're both 2. So we just add the numerators. 1 plus 1 is 2. 2/2, which is equal to 1. Next, we have 1/4 plus 1/8. These do not have the same denominator, right? So what we can do is we can convert this one into eighths. So we have 1/4. To get to eighth, we have to times 2. So therefore, with the times 2 up here, so 2/8. So we have 2/8 plus 1/8 equals 3/8. All right, let's move on to something a little more challenging. Now we have 1/2 plus 2/3. All right, so what is the least common multiple of these? 2 and 3. So an easy way to find that is to just multiply these by each other. That is always going to be at least an answer you can use. It might not be the most simple one, but in a lot of cases it will be. So in this case, we have 2 times 3 equals 6. So let's put both of these to a denominator of 6. So 1/2 equals what over 6? And then 2/3 equals what over 6? So this is times 3. So times 3 up here, 3/6. This is times 2, so times 2 up here, 4. So now we have 3/6 plus 4/6. It's going to be 7/6, or 1 and 1/6. And now we go back to multiplication on this last one. 1/2 times 2/3. So again, 1 times 2 is 2. 2 times 3 is 6. That equals 1/3. Part 5, we have word problems with fractions. So when it comes to word problems, we want to kind of identify what's our numerator, what's our denominator. So here we have, you want to split a chocolate bar equally between yourself and 2 friends. So you have 3 people, right? Yourself and 2 friends. The chocolate bar has 12 squares. So how many squares does each person get? Well, one way you can think about this is if you have 12 total, you have 3 people, you can divide these, right? So how many times does 3 go into 12? So each person will get 4 squares. If you have 12 squares and 3 people, another way you can do this is 12 divided by 3. Right? So kind of the same thing over here. So then we can see what fraction of the chocolate bar do you get? So now we think about it. If we have 12 squares and each person gets 4, then what we're looking at here is 4 pieces each over 12, right? You have 4 pieces over 12 total. And we just simplify that. So again, 4 divided by 4 is 1. 12 divided by 4 is 3. So each person gets 1/3. And this makes a lot of sense, right? If you have 3 people total, you each get 1 out of 3 pieces. So let's move on to the next word problem. You have half a gallon of juice left. So 1/2 gallon. If you want to split the leftovers equally between 4 kids, what fraction of a gallon does each kid get? So you have 1/2, and you have 4 kids that are going to share this 1/2. So what's one way you could do this? Well, you could do 1/2 divided by 4, right? 1/2 divided by 4. All right, but how do we do this problem right here? How do we divide fractions? So one is we can turn this into a fraction, right? So 4 is the same as 4 over 1. And then we do our same switch flip or copy dot flip flop. So you have 1/2, you keep the same. This one you switch, so it's going to be multiplication instead of division. And then this you flip flop, so 1/4. And then with multiplication, you just multiply across, right? So 1 times 1 is 1, 2 times 4 is 8. So each kid will get 1/8 of a gallon of juice. So now let's talk about decimals. So that was fractions. Now let's talk about decimals. So decimals are another way to represent portions of a whole number. Each decimal place can be filled with a number 0 through 9. Each decimal place also has a name. The 10th place is the decimal place directly to the right of the decimal point. So below you can see, to the left it goes ones and then tens, and then past that it goes hundreds, thousands, and so on. To the right of the decimal point, it starts with tenths. That is the first place is tenths. So it goes tenths, hundreds, thousands, 10,000s, 100,000s, millions. So as we move through the decimal places, the numbers become increasingly smaller. So each decimal place represents a division by 10. So tenth is 10 times 100th, which is 10 times 1,000th, which is 10 times 1/10,000th, and so on. In other words, as we go over, it's divided by 10. So let's go ahead and work on converting from decimals to fractions. So we know that we can work from fractions to decimals. Now let's go the other way. So important to remember here is the names of all those places, because this is where they come in handy. So to put a decimal in fraction form, it must be understood that each decimal place is a division of 10. Anything in the first decimal, tenths, place gets put over 10 in its fraction form. Each preceding decimal place is another division by 10, and thus the denominator must get bigger by a factor of 10. So as we can see here, when we have 1 decimal place, it's 10. When we have 3 decimal places, it's 1,000. We have 3 zeros. So let's go ahead and try this. So we have 0.5. So it's going to be over 10. So equals 5 over 10. Next, we have 7. That's 1 decimal place. So it's going to be 10. 7 over 10. We have 0.25. We have 2 decimal places. So it's going to be 2 zeros or 100. Right? 25 over 100, which we can simplify to 1 over 4, because 25 goes into 100 4 times. So next we have 83. So again, we have 2 decimal places. So it's going to be over 100. So 83 over 100. All right, next we have 0.03, which again is 2 decimal places. So it's over 100. It's going to be 3 over 100. All right, so next we have this one, right? 0.005. So how many decimal places is there? 3, right? So as you know, up here, it's going to be 1,000. So we have 5 over 1,000. And so this actually is able to simplify. 1,000 divided by 5 is 200. So it's going to be 1 over 200. I'll move on to the next one. We have 3 decimal places again. So again, it's over 1,000. 145. We can divide this by 5 again. It's going to be 29, which is a prime number, over 200. So next we have 4 decimal places. So instead of 1,000, it's going to be 10,000. So 1, 2. So we have 4 zeros now. And on top we have the same number, 3, 8, 7, 6. And this can probably be simplified, but for now I'm just going to leave it as it is. So next we have 3 decimal places, so it's going to be over 1,000. $305 over 1,000. On our last one, we have 4 decimal places, so once again, it's going to be over 10,000. It's going to be 7090. We can definitely simplify this one because that's 0, so divided by 10. So 709 over 1,000. All right, so that is changing from decimals to fractions. So now let's talk about adding and subtracting decimals. So when adding and subtracting decimals, the decimal must stay in the same place. To make sure of this, the number should be lined up by decimal place before adding or subtracting. Remember, you can put an extra 0 at the end of any decimal and it means the same thing. Example, 0.125 minus 0.113 is equal to 0.012. You can see that because we lined it up. It's 5 minus 3 is 2, 2 minus 1 is 1, 1 minus 1 is 0, and that's our answer. Also on the right is another example, 0.5 minus 0.05 equals 0.45, and we see it written out there. So I'm going to do the first one, maybe the first couple of these written out, and then we're just going to kind of go through them quickly. So first one we have 0.3 minus 0.3, 3 minus 3 is 0, 0.0, so that equals 0. All right, the next one we have 0.5 minus 0.3, 5 minus 3 is 2, 0.2. So 0.5 minus 0.3 is equal to 0.2. So let's go ahead and keep going. And remember, when you're doing this on your own paper, make sure we line up the decimals, right? So we see the decimal points are in the same spot. All right, so 0, 0.2, and now let's move on. So we have 0.254 minus 0.24. When you line them up, you're going to get 4 minus 0, 5 minus 4, 2 minus 2, turns out at 0.014. Next you have 0.674 minus 0.576. And when you do that, you're going to get 0.098. So 0. All right, next we have part E, 0.859 minus 0.286. And when we line those up and do our math, we get 0.573. Let's move on to part F. You have 0.07 minus 0.02. You're going to get an answer here of 0.05. And feel free at any point, you can pause the video, try ahead, try to solve these on your own before I give you the answer. Because we know how to work through it, we know how to lay it out. We have these examples here to constantly reference. But it's always good to challenge yourself, and really see how we got to this answer and see if you can even beat me to the answer. So next up, we have 0.008 minus 0.003. And when we do that, we get 0.005. And if you want some help on how I'm doing all this, all we're doing is matching up the spots, right? That was wrong. All right, so 4 minus 0, 5 minus 4, 2 minus 2, and so on. That's all we're doing in all of these problems, is lining up those decimals and seeing what we get. So in here, there, and there. So we have 0 minus 10, 0 minus 5, and 5 minus 4. So when we do that in subtraction, we know we're going to have to borrow from the 5, and we're going to end up with 0.05. So next we have 0.56 minus 0.503. And when you do the math and line up your decimals, 0.057. Last one for this, we're going to do 0.76 minus 0.34, and that's going to be 0.42. All right, let's go ahead and move on to multiplying decimals. So when you multiply decimals, it's pretty simple. You're going to multiply like you would any other number. The only difference is you're going to put a decimal point in there, right? And so the way you do this is if you take the number of places behind the decimal place in the numbers you're multiplying, and that's how many there will be in your answer. So here we have 0.4 and 0.2. So we have 1, 2. In our answer, we have 2, 1, 2, right? So now here we have 1, 2, 3. In our answer, we have 1, 2, 3. So let's go ahead and do this. You can use a calculator if you'd like, or we can definitely draw it out. So 0.3 times 0.3. So you do it like regular multiplication. So you're going to have a 9. But you need 2 decimal places, right? So here you go, 1, 2. You fill in some zeros. You get 0.09. All right, so now we do the same thing. 0.5 times 0.3. We're going to multiply these. 5 times 3 is 15. You need 2 numbers behind the decimal. So 1, 2. You get 0.15. All right, let's go on to the next one. So you have 0.44 times 0.2. 44 times 2 is 88. So you start with your 88. Then you got to put 1, 2, 3 behind, right? So 1, 2, 3. So 1, 2, 3. An extra 0. Your answer is going to be 0.088. And the next one we have 0.35 times 0.8. All right, so this is going to give you you're going to get 280. We have 1, 2, 3 behind the decimal, so 1, 2, 3. So 0.0280. All right, to the next one. We have 254 times 0.24. So you get 254 times 24 is 6,096. I'm not going to put a space. But we can see we need 5 decimals behind the line, right? So 1, 2, 3, 4, 5. So 0.06096 is our final answer. So next one we have 0.88 times 0.75. We get this, it's going to be 660. Sorry, 6,600. But we can move the decimal spot 4 because we have 1, 2, 3, 4. So 1, 2, 3, 4. 0.6600 or 0.66 if you don't want to put the extra zeros. All right, so our last one, we have 0.64 times 0.34. So we're going to get 2,176. And then we're going to move it 1, 2, 3, 4 spots. 1, 2, 3, 4. So it's going to be 0.2176. So that is multiplying decimals. So now we have a couple word problems. So let's say you have $24.87 in the bank. You buy a bucket of ice cream for $2.45. How much money do you have left in the bank? So if we have this much, we buy this much, so that means we're losing that much. How much do we have left? So this is going to be a subtraction problem. So we have $24.87, $24.87 in the bank, minus $2.45 that you just spent on ice cream. And now we just follow it down. So 7 minus 5 is 2. 8 minus 4 is 4. 4 minus 2 is 2. And 2 minus 0 is 2. So you spent $2.45 on ice cream, and you are left with $22.42 in your bank account. All right, so now let's do another decimal problem. So part B, you have $45.87 in the bank. You sell your old snowboard for $50.75. How much money do you now have? So if you have $45.87 and you sold your old snowboard for $50.75, are you adding or subtracting that $50.75? I would say adding, right? You're selling your snowboard for some money. So you're going to set it up the same, but it's just going to be addition instead. Say 45.87 plus 50.75. And now you just do it the same as you would any addition problem. So 7 plus 5 is 12. So 1, 2. 8 plus 7 plus 1 is 16. 1 plus 5 plus 0 is 6. 4 plus 5 is 9. So after you sell your snowboard, you are left with $96.62 in your bank account. All right, one more word problem, and then we'll move on to percents. So you and your 3 coworkers have $100.52 in the tip jar. So you, 3 coworkers. If you split these tips evenly between 4 people, so split it between 4, how much do each of you take home in tips? So you have 100.52 divided by 4. So what we're going to do is you're going to do this like you would any division problem. So really, you just ignore the decimal and you kind of work your way in. So does 4 go into 1? No, it does not. Does 4 go into 10? Yes, it does twice. Minus 8 equals 20. So how many times does 4 go into 20? We know it's 5. Minus 20 equals 0. Drop the 5. How many times does 4 go into 5? Once. Minus 4 equals 1. Does 4 go into 12? We know it's 3. And then all we do is we take this decimal, we bring it up here. So our final answer is $25.13 per person. Let's go ahead and move on to percents. So percents are another way of expressing parts of a whole. So we talked about fractions, we talked about decimals. Now let's look at percents. So percents are a number or ratio in respect to a fraction of 100. So in other words, 5% is the same as 5 over 100. And the way we can think about this is just the way the word is broken down. So per, we know is out of, right? So, and then we have cents, which is based off the Greek root or Latin root, cent for century or 100. So you know a century is 100 years, cents is 100. So out of 100. That is what percent literally means, out of 100. So here is an example of some switches between fractions, percentages, and decimals, or some conversions. So to go from a decimal to a percentage, you just times by 100. To go from a percentage to a fraction, you put it over 100. To go from a fraction to a percentage, you multiply the top by 100. And go from percentage to decimals, you divide by 100. So I would definitely write this down because this is very nice to have this example. You get to see it in action. You get to see what the different things are and actually how to go between them. All right. So now let's talk about this. Finding the percent from a decimal or a fraction. So we went through our conversion rules. They're going to be up here in these paragraphs. You can review them at any point if you need to. But let's go ahead and jump in. So convert the following to percent form. So we have 0.54. So already we know that all we have to do is multiply this by 100, which just moves this over two things or two places. And I get 54%. Awesome. The next one, we have 0.34. So same thing, we just move it over. 34%. Actually, we have 47 or 0.47. Once again, it's two decimal places, so it's just going to be 47%. 0.8712, so that's already out of 100. So 0.87 times 100 is going to be 87. So it's 87%. So 0.2. Here's where it gets a little bit different. So 0.2 times 100 is going to be 20, right? So it's not going to be 2%. It's going to be 20%. 0.9, so it's the same thing. It's not 9%. It's not 0.9 divided by 100, or times 100, which is going to be 90. So 90%. All right, I'm going to come back to these three because they are a little bit different. So for now, let's go on to J and look at fractions. So we have 39 over 100. So we know percents are out of 100. So right now, we can already just put that to 39%. 44 out of 100, same thing. Percent is out of 100, so 44%. 97 out of 100 is going to be the same thing. 97%. All right, so now we can get something a little bit more challenging. So we have 4 over 10. So if we go back up a little bit, to go from fractions to percentages, we multiply the top by 100 and then divide the bottom. So here, multiply the top by 100. So 4 times 100 is 400. 400 divided by 10 is 40. And we have 8 divided by 9. So this one's even more complicated, right? But it's actually going to be the same as the last one we just did. So I do 8 times 100, which is 800 divided by 9. And you're going to get 88.8 repeating percent. All right, so that 88.8 is going to go on forever and ever. All right, so then we can look at G, H, and I. So G, we have 0.993, and we can think about how we convert, right? So we multiply, by 100, right? So when you multiply 0.993 by 100, what you'll get is 99.3. So our answer is 99.3%. So you can definitely have decimals in your percentages, as you can see up here, right? Which makes it a little bit more interesting. All right, so we can go H, so 0.683 times 100 is 68.3. 68.3%. And this last one, 794, 79.4 So there's that for you. Now let's move on to converting a percent to decimals. So we just went from decimals to percents and even fractions to percents. Now we're going to go from percents to decimals. So to convert a percent to a decimal, all you need to do is move the decimal to the left 2 places. And that is the same as dividing by 100. So it's nice and easy, nothing crazy. So right here we have the decimal here, we move it there. It's going to give us 0.76 here. Move it over 2, so it's 0.49. And it's just going to really keep going for all of these. So try this one on your own. 38%, what would that be in decimal form? 0.38. And the next one, we have 28%. You're going to just move over the decimal 2 places. So it's going to be 0.28. 45, move it over 2 decimal places, 0.45. 30, we're going to move it over 2 decimal places. So again, 0.30. And then 40, same thing, 0.40. So you see this gets a little bit tedious after a minute, but hopefully it gets pretty easy for you guys to do after some practice. So over here, we have some similar ones, but it's going to be a little bit more complicated because we have the decimal point here, right? But in my opinion, I might make it a little bit easier for you because then you actually have the decimal point. You don't have to remember that it's after these whole numbers. It's already here. And again, it's the same thing. You just want to move it 2 points. 1, 2 equals 0.298. 37.4, 0.374. 20.9 is equal to 0.209. 50.7 is equal to 0.507. And now we have something a little bit different. So remember, we want to move our decimal point 2 spots. So this, we have 150. So we move it over 2 spots, 1, 2. And we see that we get a whole number, a bigger than 0, right? So all of these are 0 point something up until now. And now it's going to be 1.5. Just like that. You can draw the 0 if you'd like, if you want to show it, but that is the same, right? So 150% is the same as 1.5. So again, we have here 200%, move it over to 2.00. All right, so that is converting percents to decimals. So next we'll talk about calculating percentages of numbers. So sometimes we want to talk about subgroups of something. And one way we do this is by referring to the percentages of those subgroups. For example, a car salesperson may want to determine what percentage of their cars have hail damage. To do this, they would divide the number of cars with hail damage by the total number of cars. So as you can see from the fraction below, you put the numerator as your cars with hail damage, total cars on the bottom. So with this salesperson, he had 50 cars, 7 of them had hail damage. So it's just 7 over 50, that's your fraction. You can simplify the decimal form at 0.14 and percentage as 14%. And remember, these all represent the same value. So 0.14, 14%, and 7 over 50 are all the same value. They all equal the same thing. Cool. So let's look at some examples. So if Katie had 5 marbles and she later lost 3 of them, what percent of her marbles did Katie lose? So a way you can do this is if she had 5, she lost 3, so 3 over 5 equals our answer. That's 60%. So we have both a fraction and a percent. And if you want, you could even put a decimal, right? 0.60. So same down here, 4 is what percent of 8? So we just do 4 divided by 8 equals W, our answer. That's 50%, or in decimal form, 0.50. But for now, we're only going to be asking about percentages. So let's go ahead and try some examples. So you broke 5 out of the 10 computers you owned. So all we do here is go 5 over 10 5 over 10 is equal to 50%. Cool. Well, 4 is what percent of 9? 4 over 9. So remember, you do your top number times 100. So 4 times 100 is equal to 400. Then divide by your denominator, which is 9. And what you'll get here is 44.4%. So now we have 3 is what percent of 8? So same thing, you have 3 over 8. 3 times 100 divided by 8. You're going to get 37.5%. All right, 7 is what percent of 10? 7 over 10 equal to 70%. Erase all this so we have some more room. So 8 is what percent of 2? So we do 8 times 100 divided by 2. 400%. What percent of 9 is 3? Oh, I did that backwards. I'm sorry. That is what percent of 2 is of 8. What percent of 8 is 2? So this would be 2 over 8. So notice the switch. So 7 is what percent of 10? That's 7 over 10. What percent of 8 is 2? Is 2 over 8. So it's percent of goes on bottom. So percent of 10, bottom, percent of 8, bottom. So 2/8. So we do 200 divided by 8. I get 25%. Next one we have what percent of 9 is 3? So we have 3 over 9. 33.3%. And what percent of 10 is 6? So it's going to be 6 over 10. 6 times 100 is 600 divided by 10 is 60%. All right, so next up we can look at, you see a sale for 10% off of $60. How much do you save? All right, so this one's a little bit more complicated, right? So you have $60. And you're saving 10%. So the first thing you think about is what is 10% of 60? So 60 is in decimal form. So when we're looking at percentages, we want to divide by 10 or divide by 100, right? So if it was 1%, we divide by 100. If it's 10%, we divide by 10. So divide that by 10 equals 6. So you'll save $6. Next, you see a sale for 45% off 100. How much do you save? So again, this is 45 out of 100. What percentage is that? We know if it's out of 100, it's already in percent form. So we're going to say $45. And finally, you see a shirt on sale for $45. Its original price was $60. What percent discount did you get? So there's a couple ways you can solve this. So first, I'm going to do 45, which is the price you paid, and 60, which is the original price. Right? So and when we do 45 divided by 60, you get 75%, right? 0.75 or 75%. But this is not the discount you got, right? That is how much you paid. So to get the discount, you'd find the opposite. So if it's out of 100% minus 75, then you get a 25% discount. All right, let's go ahead and move on to the next section. So that was all we're going to do from part one, or section one of part one. So fractions, decimals, and percents. So now we're going to work on exponents, and we're also going to work with some radicals. All right, so just a refresher, here are our rules. So exponents are a way to write repeated multiplication of the same number. For example, 5 to the 2 means 5 times 5. 5 to the 3 means 5 times 5 times 5. Exponents can be negative or positive values. The following rules show how to complete algebraic problems containing exponents. So there's a huge hint here is watch your signs. If you have a negative exponent, make sure you keep it negative when you're working with it. And if it's positive, make sure that you write it positive. Now, it might change after you actually solve for it, but when you're writing it out, make sure you're paying attention. Another hint is notice the base of the exponent. So if a rule says a couple times, a is the same number every single time. So a can only stand for 3, let's say. It can't be 3 and 4 in the same rule if it's a. A is only one number, and b is a different number. So let's go see and get some practice. All right, so first off, we have 3 squared times 3 squared. So does this look like any of our rules? We can see it does. It looks like the product rule, right? So we see the way that we solve this is just by adding our exponents. So 3 squared times 3 squared is equal to 2 plus 2 is 3 to the 4th. All right, which also is equal to 81. For now, we're just going to keep most of this in exponent form, just to keep it simple. Right, next up, we have 2 squared to the 6th. So this doesn't look like any of our rules above. So it looks like the power rule, right? So you have a times x to the y, 2 times 2 to the 6th. So what we do here is we multiply them. So 2 times 6. So this is going to be 2 to the 12th. Okay. Next up, we have 4 times d squared. Does this look like any of our problems above? Let's say it looks like our power of a product rule, right? So what this says is that if you have 2 values inside of a parentheses to an exponent, that exponent can be individually applied. So in other words, it's going to be 4 squared times d squared. And that is the same thing. All right, next up, we have 9 to the 0. Does this look like any of our rules? 0 exponent, anything to the 0 equals 1. So this equals 1. All right, next up, we have 2 over 4 to the 2. Does this look like any of our rules? I would say it looks like power of a fraction. So we have 2 squared over 4 squared. All right, next up, we have 6 to the 5 divided by 6 to the 3. Does this look like any of our above rules? Yes, it looks like our quotient rule. So we just subtract our exponents. So 5 minus 3, so 6 squared. All right, now we have 6 squared divided by 3 squared. So does this look like any of our rules? I would say maybe it looks like our power of a product rule, just reversed, right? It's this side, but even then it's division. Yeah, so I'm not quite sure. But we can look, definitely. We can kind of explore through some of these. So we have divided. So is A the same? No, right, because it's 6 and 3. All right, so I would say we kind of just leave that how it is. Because we don't have the same, right? We have 6 and 3. So this would be, in this case, A and B. And I don't really see any a divided by b up here. I guess there's this one, which could be applicable, actually, now that I'm looking, right? Because this could also be written as 6 squared over 3 squared, right? Which means we can write it the other way as a over b squared. So 6 over 3 squared. So my bad, it was the power of a fraction rule. a over b to the same x, you can change it out. So these rules do work both ways. That was a good reminder of that. So good. All right, so next we move on to this one. So we have 2 times 2 to the negative 1. So remember 2, any number by itself is 2 to the power of 1. So when we put it this way, it's kind of a little bit more obvious what we have, right? This is going to be a product rule question. So it's going to be 1 plus negative 2. In other words, 2 to the negative 1. And it could also be a negative exponent question, right? So we can go 1 over 2. All right, next up we have 5 to the 2 times 5 to the 3. This is going to be another product rule question. So it's going to be 5 to the 5. Next up we have j, so we have 3 to the 2 to the 3. Again, this is going to be a power rule problem for us. So we multiply, so this is going to be 3 to the 6th. And then we have 2 times 3 to the d, or 2 times d to the 3. So very similar to this last one over here. It's going to be a power of a product rule. So you need 2, 3 times d3. All right, next up we have 7 to 0. And again, that's that 0 exponent that equals 1. Then we have 4 over 3 squared. So again, we can distribute that too, right? So we have 4/3 squared is the same as 4 squared over 3 squared. Well, next up we have a division or a quotient rule problem. We have 8 to the 5 divided by 8 to the 3. So we just subtract those. So it's going to be 8 squared because of that. And finally, we have 3 to the 1 times 6 to the negative 2. So does this look like any of our above problems? So we have a and b, 2 different exponents. I would say it doesn't. So I would say this, just leave it as it is. Because I don't see any up here where there's a to x and b to y. All right, so now we can go ahead and move on from this section. So now we have radicals. So radicals are the opposite of an exponent in the same way that addition is the opposite of subtraction. A square root is a special type of radical that removes an exponent of 2. So here are our rules, and here are some examples. So these rules don't get the fancy names that we give to our other ones that we have with our exponents. They have the rules. These ones don't have the names as much. We just kind of have the same principles though. So review these principles, definitely write all these rules down really quick. It'll help you a lot as we continue to move through. And as you continue to move through your math courses in general. So nth roots of a positive number. So finding the nth root of a positive number is the opposite of raising a number to the power n. So here we have a n to the nth root. So when we say to the nth root, this is what we mean, this n. So if it's a 2, then it's to the second root or square root. If it's a 3, then it's to the third or a cube root. Okay. So another way to think about radicals is by factoring out the expression, and then only if you have n number of at least each least common factor can exit the radical. In the radical above, n is 2, and there are 3 2's that can leave the radical. Another way to write the same square root is with an exponent. An exponent with a fraction in it is a radical. All right, so here's some examples. and then we're gonna do some practice problems. So we have square root of 25 is equal to 5 squared. And as we kind of talked about, there's a little 2 on all of these, right? So because there's 2 here, they cancel out. We get 5. 64, same thing. Again, 25, we already saw that one. So this one's nice because it shows us that cube root, right? So you have the cube root of 125, 5 cubed. Take out those 3s, you get 5. 512, you get 8 to the 3rd, which is 8 to the 2nd times 8, or 8 square root of 8. Okay. Don't have to worry about this one as much, but definitely that. All right, so let's see some problems in action. So the square root of 49. What is the square root of 49? It's 7 squared, right? 7 squared, we can cancel out with this. Our answer is 7. Awesome. Next up, we have 225, square root. So here we could do, let's see, I believe 225 is the cube root of 5. Oh, no, it's not. It's 15. So 225 is the square root of 15. So again, those 2's cancel out. Our answer is 15. Square root of 36. 6 squared. 6 times 6 equals 36. We're left with a 6 out here. All right, so now we have some cube roots. So it's cube root of 27. 27 is 3 cubed. So those cancel out. We're left with 3. All right, cube root of 343. You're going to get 7 cubed, which means your answer is going to be 7, right? Because these cancel. And finally, we have the cube root of 64, which is 4 cubed. Cancel out those 3's. Your final answer is 4. All right, so here's where it gets a little bit more complicated, right? So we have the square root of 27. So as we kind of talked about already, the square root of 27 is 3 cubed, right? So now these 2 and that 3, they do not match, right? So they don't cancel each other out how we've been canceling out in other problems. But what they do is they subtract from each other, basically. So we'll take out this 2. We'll take out one of these, or 2 of these, but there's still 1 left, right? So what that means is we still have 1 3 inside, we have 3 outside. Right. Another way of writing this is we could do something like this. So we know equals 3 cubed, or also we could put 3 squared times 3, right? Because then we can really see where the cancellation comes from, right? The square here, put that 3 right here, and that's still inside. So here's our answer, 3 square roots of 3. All right, so let's go ahead and try number 8. So number 8, or sorry, h, the square root of 8. You know, 8 is the cube root of 3, or of 2. So 2 cubed is equal to 8. So again, we can do the same thing over here, where equals 2 squared times 2 equals 2 square root of 2. All right, so 75 is going to be a little bit different, right? So this one's not a cube root, so we kind of just factor it out. So what this is 25 times 3, which is equal to 5 squared plus 3. Not plus 3 times 3, I'm sorry. So once again, we cancel out, right? 5 squared, we can get rid of that squared, it gets outside. So now we have 5 square roots of 3. So go ahead and try J on your own. Go ahead and pause the video, we'll try it out, and then we'll see if you can get it on your own, and then we'll come back together and work on it. All right, so hopefully you attempted J by yourself. Let's go ahead and try it out. So 4, it's gonna be the same process as that last one, right? So we kind of are working through the square root. So we factor 12, it's gonna equal 4 times 3. All right, we know 4 is this 2 squared, right? The square of 2. So once again, we're finding ourselves getting this out. So the 2 squared can come out if we cancel out the exponent, right? So this equals 2 square root of 3. All right, last one. It's going to be pretty similar, but we're going to simplify out looking for a number that is a square. All right. So in this case, we have 6 times 4, right? Because that 4 is 2 squared. So then we can take that 4 out, and what we get is 2 square root of 6. All right, so that is how we simplify radicals using our rules that were above. So now we'll move on, and we only have, I think, one thing left. Yep. So scientific notation. So this was not covered in the lecture videos. It's just a little bit extra something you get for doing the practice problem video. So scientific notation. This is how we deal with numbers that are very, very large or very, very small. So imagine counting how many stars are in the sky, seeds that exist on all raspberries in the grocery store, number of people in the world, or how many calories you've eaten in your entire life. So on average, a human will eat this many calories in their life, right? And that is a huge number. Let me see. 65 million calories. And there are approximately that many people in the United States, right? So if you want to look at how many people all the US citizens will eat in their lives, or how many calories all the US citizens will eat in their life, all the US people, you multiply the calories by the number of people, and you get this gigantic number, right? So it would be very easy for us to miss a 0, add a 0, or kind of just mess up this number because it's so big. So this is where scientific notation comes in. So this is a system we can use that makes big numbers look smaller. And they are still the same value, but it kind of just helps us make it easier to work with. So scientific notation is written as n, big N times 10 to the little n, where big N is a number between 1 and 10, and little n is the exponent to which the positive or negative integer. So if the decimal is moved to the right, the exponent is negative. If the decimal is moved to the left, the exponent is positive. So here's some examples of that. So here we have 568.572. So we know we want a number between 1 and 10, right? So we can get this value 5. We're going to move this to the left 2 spaces. And since we move to the left, the exponent is positive, 10 to the 2. So 2 decimal places, so it's 10 to the 2. Let's try a couple more examples. So you have 58,000. So if you move the decimal place 1, 2, 3, 4 places, to get 5.8 times 10 to the 4, because we moved it 4 places. And the rest are pretty similar, the other examples here. So let's go ahead and try some practice problems together. And then we'll be all done with practice problems for part 1 of IPREP. So here is our first number. We have 0.000006. So what we do is we get this exponent, we move it, right? 1, 2, 3, 4, 5, 6. So 6.0 times 10 to the negative 6. And this is important. So remember, if we move to the right, the exponent is negative. If the decimal point moves to the left, the exponent's positive. So this, we move to the right, so our exponent is negative. All right, cool. So let's look at our next one. We have 60. So we have this exponent, we move 1 to the left. So we get 6.0 times 10 to the 1. Because we only moved it 1 decimal place. Cool, so now let's look at some more. So we have 0.15 times 10 to the negative 2. And we're trying to put that into a better form, right? So we have to move the decimal place over to the right. And if it's to the right, we know it's going to be a negative decimal. So we're going to have 1.5 times 10 to the negative 3, because it's already at negative 2, and we're moving it 1 more spot. So it's from negative 2 to negative 3. All right, next up, we have this giant number here. So let's go ahead and see how many spots we move. 1, 2, 3, 4, 5, 6, 7. So 7 spots. So you have 9.5 times 10 to the, is it positive or negative? We move to the left, so it's positive. 10 to the 7. All right, now we have 0.775. So we're going to move this decimal place 1. And it looks like just 1 spot, right? So now we have 7.75 times 10 to the negative 1, because we moved to the right, so it's negative 1. And so finally, we have 33 times 10 to the negative 3. Our decimal point moves 1 to the left. And if it moves to the left, it means it's going to go positive. So we have 3.3 times 10. And remember, we have to work against what we have. So it is positive 1, but we already have negative 3. So negative 3 plus positive 1 is going to be negative 2. So that is all we have for IPREP practice problems. I hope this was pretty helpful. Feel free to review this video and all the other videos as well if you feel like there are any topics that you could use a little bit more help on. Thank you so much, and I hope you have a great day, and check out the rest of our IPREP videos. Thank you.